Great. Um, I think we're live now. Can you hear me here? Why? Please confirm that you can hear me. Like, can I hear you? I can't
Yeah, I
hear
can.
you.
I can hear you.
Okay, good. All right. So, hello guys. Welcome to our next, conversation around let's talk about AI. And today we are going to be doing a little bit of justice to, you know, the buzzword within the African, or let's just say within the AI space right now, synthetic data, right? So today we are going to be talking more about synthetic AI, and we're going to be focusing on how synthetic AI is helping a lot of businesses grow. It's just going to be a conversation between myself and Ayomide over here. So let me do a little bit of introduction, right? So Ayomide, as I usually call him, AY, is head of research at RedClaps. So most of our research works around synthetic AI, computer vision, NLP, reinforcement learning, and the likes. He's been the one, pushing the frontiers within that space for us. And a couple of people have, you know, reached out to us regarding this synthetic AI of a thing, right? Most importantly, relating to the product you are building, SynX, right? And there's been a lot of questions, and we're like, okay, let's bring this out to a conversation whereby we can give clarity to a lot of all these things. So it's actually going to be a very, very it's going to be a very, very interesting conversation. We're going to touch based around most of all these things, most of all these worries around synthetic AI, the buzzword around synthetic AI, and a lot of other things like that. All right. So before we go into the nitty-gritty of everything we're going to be talking about, Eva, do you have one or two things you would love to say, to the audience?
Oh no, nothing at all. I think you've done all the introductions. Yeah.
Okay, great. All right. So first and foremost, right, I'm very, very certain, when we pushed out this webinar thing, a couple of people, gave some questions, right, on the form, right? And some are newbies, some were, so let's just start with the fundamentals. Let's speak it from the fundamental level. What exactly is synthetic AI? What's synthetic AI all about? So I know it's going to be a conversation kind of a thing, but I'd love you to start. What do you think synthetic AI is all about?
All right. So the basic idea or the justification for synthetic AI is the fact that AI in itself is all about data, right? If you are going to train, say, an image recognition system to identify faces or people in images, you need data. And data can be pretty much expensive to collect and to annotate. And trying to find the right data can also be a big issue. So when you come down to fields such as medical fields where you require medical data, either to build a model, the problem is you have licenses upon licenses that you have to get to be able to have access to data. And there's also the issue of privacy, right? People cannot just hand over their data to you, right? So all these issues are actually the motivation for synthetic data, which is, okay, why don't we find a way to actually generate data from the computer that are quite similar, the word similar here in quotes, right, are quite similar to what you would obtain from the real world, right? So the idea is, in a more mathematical term, is more or less like getting data from the computer whose distribution is quite similar to the distribution you would get from the real word, because every single data we collect has a supposed distribution from which they are drawn from. So the idea is, okay, I can't access this kind of data like medical data and so on and so forth, and I get the computer to actually generate this data for me, and so that I can actually use it to build my model. So that's like the foundation, the motivation for this whole thing.
Okay, so that's interesting. I think you already touched based around the most important and the fundamental things around synthetic, synthetic AI. So let me just, add a little bit of gist to what you said, right? So to me, synthetic AI is more or less like generations of, data that are not captured by humans or informations that were not gotten from humans, right? More or less like information generated by the computers, right?
Mhm.
To look very, very similar to what, you know, to look very, very similar to the real human data. It could be CSV data, it could be image data, it could be video data, it could be voice, it could be, you know, all form of information, right? It could be text data, right? And generally, the essence of this synthetic data is to actually help enhance, most importantly in the AI space. You can't build an intelligent system or you can't build an intelligent um, compute system without necessary or without enough data, right? So the essence of synthetic data in the aspect of AI is to actually complement, right, AI itself in such a way that the system is much more intelligent, right, based on the information given. Because the real truth about AI is that your AI system is as intelligent as the data you feed it, right? And we know that there's this problem around data, most importantly when it comes to images or video data, with respect to what you want your system to actually learn and all, right? So um, thanks for that, right? So let's address this question. Why do we need synthetic data? Like, what's the need for synthetic data? Is synthetic data is it really relevant in our world today, right? Is it of advantage to us in any way, right? So why do we need this synthetic data of a thing? How can it help us, right? So anyway, what we have to say about that, then I'll just add some things, one or two things
All
to
right.
it.
So coming from say a country like ours, Nigeria and Africa at large, data collection is still something we are far away from, right? In the sense that we are still very much new to data collection. So when you take a look at say a field like natural language processing, people have been collecting data on natural language processing since way back the early 1960s. We've been having the first data set coming into that field, but none of them are actually representative of what we have in Africa here, right? And that's because it's only recent that we actually got into AI data collection and so on and so forth. So you can have researchers working on a particular problem in Africa and they don't particularly have access to data, or the data is unavailable. Synthetic data can actually grant them the power they need to be able to generate the data they need for their experiments, right? So if you have medical researchers trying to work on a particular problem that requires probably personal health records in, say, Nigeria, or personal health records, say, in Ghana, they could actually generate the data from just using their computer without necessarily having access. If okay, so let me come from this angle of, okay, if you have little data, right, and you don't know the data you have is not particularly enough for the experiment you want to perform, you could get a synthetic data generator to augment your data for you by generating samples that look exactly like the data you have. So these are ways by which people could actually um, benefit from synthetic data. Another one is financial records. Financial records are not things you have lying around like audio data sets or video data sets. These are data sets that are actually very difficult to get. But if you have as little as say 50 rows of those data, you could actually generate more and more and more from just the little data set you have to become a large data set, which you can then use for your experiment. So on the side of okay, performing experiments very fast and having access to data, that's actually very, very important. And also black swan events that are more or less like outlier events. The trying to get data on them can be very, very difficult. So a good example is credit card fraud detection. It's not you have an unbalanced data in that aspect, in the sense that definitely whatever data set you have, the credit card fraud detection problem is going to be far less than those people that don't experience it. So trying to balance the data, what you have to do is the typical way is to downsize the class that is the largest, or to kind of upsize or upsample the class that is the lowest, which is where synthetic data can also help to generate data for events that are not so common, but they are very, very important.
Yeah. So thanks, AY, for adding, giving those clarity to and those examples, which is more of what we have been doing within our SynX platform, right? To actually help businesses and organizations to generate this synthetic data for their experiments. So, you know, just to add to what Ewa has been saying, right? One of the reasons why we are actually solving this problem, right, or what's the need for synthetic data, is that there are a lot of experiments, a lot of businesses want to conduct with respect to AI, and a lot of them don't really have these data that they could work with, right, in order to actually perform these experiments, right? Some have these data, but the data are not sufficient, right? So it's one of the reasons why we are building a platform that can synthesize any form of data that you might be working with or that you might be working on, right? So it's more or less like the closest thing, or in fact, sometimes it's always much more better than even the real data you might be thinking about, right? And we know that it's there's this data problem within the African ecosystem. There's not enough data around this, around that, to be able to build AI systems, right? And which the reason why, SynX, or the synthetic platform which we are building, is really solving all those problems, right? Okay, so I don't want us to talk so much about this. I really want us to get a little bit deep about why we are doing this synthetic thing. So what exactly, AY, I want us to talk about the rudiments to synthetic data. What are the rudiments, right? Like if, what exactly are the things that makes up a synthetic data, right? So I really want us to address that. What do you think? What would you love to say about that?
Oh, okay. So, so let me start from a visionary perspective. So the visionary perspective is that going forward, people won't have to necessarily have a little bit of data to be able to generate synthetic data. So you could actually just type in your use case and generate synthetic data on the fly. But right now, as it stands, if say for example, I'm trying to get data for medical records. The way the pipeline works right now is that you need a little bit of medical records that kind of represent what you are trying to generate. So there might be 10 rows, 20 rows, 30 rows, based on how many rows you can actually get. By rows, I mean observations, based on how many observation or data points you can actually get, right? So the idea is that you have this probably CSV file that consists of your table, your rows and columns, your data points and everything. And you want to go from, say, 20 or 30 data points to 10,000 data points. So what you do is that you feed this data, this your CSV file, into the model, the synthetic data generator, which um I'll come back to it, but let's treat it as a black box right now, which is a black box, right? And you sort of feed in these 20, 30 data points you have, and from there you get a lot of data points, your 10,000 data points. So basically what the black box is doing, or what the synthetic data generator is doing, is that it's trying to understand what is the data distribution of this data I'm seeing. By data distribution is just like trying to understand where exactly is this data coming from, what are the features of this data, so that I can use these features to generate more data that are quite close to what I am seeing. So from a technical point of view, from an not an extremely technical point of view anyways, from technical point of view, for those interested in the math, you could say it's trying to learn what you call joint probability distribution of the data. So if the columns are like the features, the individual features of your data, then what you're trying to do is that you're trying to learn the joint probability distribution of your features, such that once I understand what exactly the data distribution is, then trying to get other data points from it becomes very easy. And one model that does that in machine learning is, definitely some people must have guessed it, that's your generative adversarial network, right? You have like a discriminator and a generator, and basically what the generator is trying to do is to get as close as possible to the data distribution of the original data set. So it starts with a Gaussian noise, so to say, Gaussian distribution random noise, and it tries to tune and tune and tune until it gets very close to the distribution of the real data. And these kind of models are the models you find um, in your synthetic data generator. There are models that try to learn the joint probability distribution of the data you fed in. Like I said, the vision is to get to a point where you don't even need to feed in any data at all. But as it stands now, you have to feed in data into it. It learns the distribution, then it's able to draw more data from that particular distribution. So that's like the basic pipeline.
Okay, so thank you, Y. You you know, it's more or less like you are making me not say so much about things that. So you've actually said most of all those things. So let me just add, right? So basically, the rudiments to synthetic data as it applies to SynX, right, is that just feeding your data, right? For now, our system is kind of capturing just CSV, data. We are still working on the image data and then the video data within our platform, right? So you feed in your data, maybe just a little sample of your data, and then it generates more samples of those data by just looking at the distribution of the data you fed in, and then it's able to generate more samples, and then you models go ship your stuff into production, and then get your AI system up and running with your end users and the likes, right? So let's move on to something much more deep, for the technical guys. So you made mention of generative models, right? So I just wanted to just say one or two things about, synthetic data is a lot of businesses doing that within the AI space are either doing it the generative way, right? Generative models. Some are using language models. I just wanted to just say one or few things about, this area. When it comes to generative models, what do you have to say with respect to synthetic data? When it comes to language models, right? What do you have to say about that with respect to, synthetic data, and how we're actually doing that at SynX?
Okay. All right. So for language models, of course, we know that with the advent of transformer models, we've seen results around zero shot learning, where you don't even have to present any data point, and it's able to generate text data on the fly. And you have few short learning cases where you just present it just a few data points, and it's able to generate data on the fly. But essentially, what a language model is doing, regardless of how complicated it is actually learning joint probability distribution on some set of tokens. Now, depending on what aspect you are looking at it from, if you are looking at it from the aspect of text data or the aspect of NLP, you can say the tokens are actually words. And we've seen cases where the tokens are not essentially words, they can be what you call subwords, right? And so the idea is that you pass in some set of tokens into this language model and it's supposed to learn the joint probability distribution. So when you take a look at um, systems like Gretel that have large language models embedded in their systems, well, what you see is actually a way to tokenize whatever data you pass into their system so that the large language model, transformer-based models like GPT and so on and so forth can actually learn the joint probability distribution on the token. So essentially, the intelligent or the ingenious part is actually how you can take either images or tabular data and tokenize it in such a way that the language model can actually learn the joint probability distribution on those tokens. So that's basically, and when you look at it a lot deeper, right, the joint probability distribution is all about giving a particular token predict the next token and giving the previous token predict the next token and so on and so forth. That's essentially what the language model is trying to do, right? It looks at the past and trying to predict what should come next. Now,
Exactly.
in the case of GANs, generative adversarial networks, the vanilla GAN, which was the one introduced by Goodfellow, is people have shown over time that it's not very good at generating synthetic data, particularly tabular data. It's good for images, very, very good for images. That's why we have things like DC GANs, deep convolutional GANs, which are very good at generating GANs. Then you have style GANs and so on and so forth. But when it comes to tabular data, it's not very, very good at generating tabular data. And two problems basically. The first one is that some columns in the tabular data might have a multimodal distribution, which is basically saying that you might have like two peaks in your distribution when you draw your distribution. And another problem is the problem of data imbalance. How do you handle data imbalance in a case where you have a categorical column and you have some classes being more represented than other classes, right? So that's where the idea of conditional tabular GANs came in, which is an attempt to actually solve these two problems, right, by having what you call a mode specific normalization. Basically, the idea is that, okay, all the columns that have multimodal distribution, try to learn the multimodal distribution using a, a mixture model, a Gaussian mixture model, which is just layering bunch of Gaussian models on top of each other to simulate what that column is. Then have a conditional generator for columns that are not so columns that are imbalanced, categorical columns that are imbalanced, such that you can represent those classes that are not well represented. So these are like the two, these are like the things that conditional table GANs, tabular GANs actually bring to synthetic data to make GANs more effective at generating tabular data. So like I said, GANs are extremely good at generating image data. Language models are extremely good at, transformer models are extremely good at generating text data, and they can also be used to generate other kind of data. And of course, you now have city GANs, conditional tabular GANs that are super good at not, I won't say super good anyways. I think that's kind of by exaggeration, but they are good at actually generating tabular data.
Tabular data. Yeah. You've pinpointed most of all those things, which is actually the importance of generative models, right? So they all have their use cases, right? The ones good for tabular data, the ones good for what do they call it, image data, video data, audio data, and the likes. Okay, so there's been this release of this DALI um, stuff, right? So what do you have to say about it, right? And then when it comes to stable diffusion, what do you have to say about that with respect to generative models, with respect to images and then video data? I just want you to just say one or two things about stable
So,
diffusion, DALI 2 and DALI 2 and the likes.
all right. So I think let me start by saying that the only reason why some of these companies can do what they do is because they have access to large compute and large data, right? Like the for stable diffusion, I think there was a time the co-founder of stable diffusion,
Mm-hmm.
uh, the company that is in charge of the algorithm, put it out there that it cost them about close to like $50 million to actually train their models. So there are some models that are in fact very, very capital intensive to train. And DALI 2 and imaging, Google, OpenAI, of course, we know these guys are juggernauts at what they do. So it requires, of course, there are smart things they've been able to incorporate
Mm-hmm.
into training these models. Some of the things they've actually introduced, such as self-supervised learning techniques like contrastive learning and also self-supervised learning, which we already know from NLP, things like word embeddings, right? But they found a way to actually do these things in an efficient way. But at the same time, they could do these things because they have access to a lot of data. I mean, Google is
Large
like the custodian of the internet, right? So they have access to this data that allows them to actually do these things. And I think one thing some of us can aspire to do is to pick up some of this pre-trained model. Um, Thank God for transfer learning and domain adaptation. Then go use them on what you can actually do. But I think I've read somewhere. I've not tried out stable diffusion really on my own, but I've read a couple of things on it, and I think people often say that regular generative models are faster than stable diffusion when it comes to probably training, but I think they produce more quality results than generative other generative models. And foundation, when it comes to the foundation, I think they are energy-based models too. And stable diffusion are energy-based models. So these things can only be possible because of it can only happen through the people that built it, the likes of Google, OpenAI, and the rest. So it's not something a regular startup can actually do. It's something they can do because of who they are, right? So picking their models and trying to use it for whatever we want to use it for is the best we can actually do. Like I said, also on the algorithm side, they've been able to introduce a lot of smart um, things into the algorithm side. But overall, data accessibility to data is actually driving some of those things.
Yeah. So that makes a lot of sense, and we thank God for the things these guys are really doing and how this has really contributed to the to the AI space, right? So
Mhm.
I want us to just do a little bit of wrap up, and so basically, right, these guys have done so well. In at least I was so excited, seeing stable diffusion and possibilities around how it's able to generate very, very awesome realistic images. You can even, more or less like you already have more like your AI Photoshop, right? Something that you feel like you sometimes, sometimes people feel like, wow, this thing is real, right? But it's something that was generated by the computers, and that really shows, the potential of AI itself on how it can actually make, things so real, right? And I'm so glad that these things are really, really happening. So
Yeah.
now, with respect to SynX, we are building um, synthetic X, or let me just say SynX, as a platform that can actually synthesize, you know, what the problems you might be trying to face, you might be facing at your startup or whatsoever relating to data. right? To building your next AI models or your next AI systems, right? And then, like we've been saying, our SynX platform has been fully based on the usage of generative models and language models. Of course, we are still coming up. We are getting close to the aspect of synthesizing image data and the likes. And one of the reasons why we're doing this, we are just trying to, you know, be beside Mr. Google and the likes, Also, we are trying to do all of these things in order to give more flexibility to a lot of startups that might be willing to build their own AI system, and they could probably, of course, you having bottlenecks with respect to the data, right, in order to build those things. All right. So, but I just want to say, okay, I just want to know how this platform, SynX, that we are building, how is able to drive business growth, right? So SynX, so far, with testing our platform, right? It's been so rapid for them, right? So many times, a lot of companies, it takes them a lot of months, a lot of you know years and the likes in order to be able to build their MVP. Now, the reason why we are building Synex is the most times businesses don't really have problems with the modeling, right? At times it's the data itself. The data could be the problem, right? That is, sometimes, most times, a lot of businesses, when they spend a lot of months or a lot of years trying to build something, right? It might not be the problem of the model. Sometimes models could be the problem, probably using the wrong model for the wrong case scenario, right? But at times it could be using the right model for the wrong data, or using the wrong data for the right model, right? And that's the reason why we are building Synex, right? We noticed that it's more or less like a bottleneck to a lot of our users with respect to Red Vision. Red Vision happens to be an end-to-end platform that helps you to build your own AI system, or create your own AI system, or synthesize your own AI system, or build your own AI experiments within a short period of time. We know it costs a lot of businesses, thousands of dollars, right? You know how to build AI systems, and it takes them a lot of time, right? And we are building Synex right now because we believe that, and we've seen with a couple of our users, that they're having data problems. Sometimes it's not the problem of the model, it's the problem of the data you're trying to work with alongside the model. And that's why sometimes you get bad results. And that's why sometimes you're getting poor results, and you keep trying, you keep fine-tuning, putting a lot of money into large computation, which is actually not necessary, right? So we are building Synex for people like you that might be faced with this kind of difficulties. No technical experience required. All you just have to do is to feed in the right set of data, right? And we help you generate more. And at times, it could be that you just have to, we are getting to a point whereby maybe, of course, the image part, which is one of the things we are still working on, but whereby you just have to just type what you want to be able to build, right? And we're able to generate the data that can help you accomplish what you want to build. Of course, you've got to give us some samples of what you actually want to be able to build, right? With respect to some of our like you consulting us and telling us, okay, this is what you want to be able to build, and this is the kind of data you want to be able to work with, and then we can give a recommendation. Oh, this data is going to work well. This one is going to work well for what you're going to build, right? Synnex is to help you get so fast to building that AI model with the best of accuracies, right? And we're getting to a point whereby we can actually generate more images, we can generate more video samples for you to be able to build that AI system within little or no time on our Red Vision platform, right? So, anyway, I just want you to just add one or two things, right, when it comes to what's the relevance of Synex, and how are we actually dealing with differential privacy. A couple of people asked that question, right, saying, oh, we generate these data. What are the other benefits of just generating data on Synex platform, and how are we dealing with privacy, right? Then after that, we talk about the metrics, right?
All right. So I think you've mentioned everything already. Some of the things we are trying to do is to ensure that we comply with this issue of privacy, right? And we try as much as possible not to, we try to penalize the model from generating samples that are already in the data set that has been fed in, right? So that it doesn't just regurgitate the data set or something uh, very, very realistic. So you have to kind of encode your data in such a way that there is no data leak during the generation phase. So some of the work we are working on is to ensure that we're able to at least comply with those rules when generating model, and that's like you mentioned, differential privacy is one of the things we are also looking at, and how to better incorporate it into our system. These things are still more or less like ongoing research for us also, and we are also learning, right? So we are trying as much as possible to make sure that the model doesn't just learn information that are very, very sensitive, but it learns just enough to be able to allow the data scientists, because way back when we're trying to deliberate on what the business objective should be, we concluded that being where we are as a continent, as a country, medical data and financial data are the best things to actually look at the moment. And we know that these are two sensitive areas when it comes to data sets, data generation. So we're making sure that if we are going to be generating data in this aspect of financial data and medical data, we don't have any data breach or any data leak during the generation phase. So um, differential privacy is also something we are actively looking at to really incorporate into our pipeline.
All right, all right. Thank you, Y. So I just wanted to, before I talk more about some of the benefits of using SynX, right? Because one thing I really want to pinpoint, for instance, businesses that are, for instance, financial businesses or financial fintech platforms, right? Whereby you might be doing some level of data analytics, and you've got a couple of developers or data scientists that need to work on some of these data. These data are very, very sensitive data, right? Some of the data they've been getting from their users, very, very sensitive. And they want to run some level of analytics, right? One of the essence of SynX is to help you generate samples, right, of those data that you really, really have to look like as see they are actually the real data. And you can actually use that for your workflows, for your testings, for your development with privacy protected. So the data has been generated, right, as this privacy being protected. And when you look into them, they don't look like as if they are real data, right? They are not real data, but the performance metric of these data with respect to your real data are the same thing, right? So thereby giving a lot of fintech platforms the flexibility of sharing their data with their team members and other counterparts or whosoever that might need some of these data to work with, right? In fact, one of the major problems around people not being able to build a lot of AI systems within the African ecosystem is that a lot of companies just keep their data to themselves because of privacy, right? But of course, with SynX, you can actually share some of these data across your teams, across people to work on it and help you actually give you more insights with respect to your systems, your businesses, right? Also, with SynX, right, it can help enhance your customer analytics, right? It can also, for your software development and testing, you can actually generate data samples that actually looks like real data, like as if you're actually testing your softwares, right? So with the SynX platform, you should be able to generate data, right? No, we're not talking about dummy data. They are different. They are different from dummy data. Synthetic data are not dummy data, right? And we need to make that clear, right? So you can actually test your softwares and do a lot of other things with respect to synthetic, data. And then you can also use it for pattern trends and projections and you know the fraudulent activities detections and a lot of other things, right? So AY, just to wrap up, I'd love you to talk about what are the metrics, right? When people look into our platform and they're like, oh, can we really believe the data you guys are generating? This looks awesome, right? But the fact is, how do we really know that this is a good data to work with? How can we trust the data? So what are the metrics? I would love you to just pinpoint some of the metrics that we are working with, right, in order to guarantee them, high level data with healthy data with very, very awesome differential patterns.
All right. So I think from AI point of view or from AI level perspective, at the end of the day, people want to be able to train their model on a lot of data, then go ahead and use this model in the real world, right? Deploy into production. So which means that just like in the case of normal machine learning, where you have to split your data set into train, validation, test, or train and test, right? So we have this metric called machine learning efficacy, which was introduced by the author of conditional tabular GAN, which idea is just okay. So now you have your model, right? You train your model on the synthetic data which you've generated, then you try to test on the real world data to see what how it performs, right? So it's just like saying you are trying to do like a classification problem, like spam arm problem or email classification problem, or yeah. So yeah, exactly. So you generate your data set, then you go ahead and train you train your model on the synthetic data, then you go grab a real live data set. Your model that you've trained on the synthetic data, you try to test it on the real live data set and see if the synthetic data has actually helped your model in learning what it needs to learn or what is representative of the data. And once you compare, you can tell that, okay, I think this thing actually helped has actually learned, even though I have trained it on synthetic data, but it's performing well on the real data set. So this is like what is called the machine learning efficacy metric. And I think for me, it's the most important metric, because at the end of the day, you want your model to be in production and you want it to do well on real data, despite the fact that you've actually trained it on synthetic data. So these are some of the...
In the short term, we are basically trying to like say SynX helps people to actually ship out their models as fast as they can.
Yeah, as fast as possible. Exactly.
Yeah. Keep going. Keep going.
Yeah. So another metric which you are looking at is along privacy, right? Which is okay. Now I've generated this data. How well has this data learned, or how well has it encoded the data set that it has learned from? So you don't want data leak, like I said earlier. So for example, if you have important data, if you have important columns in your same medical records that can be used to efficiently identify a real life person, you don't want these things to actually get into your synthetic data. So there is the metric that tries to measure how well your synthetic data, how private it is, so to say. That is, okay, now that I have this data set, because it's really a big, privacy is really a big issue. Just like we have in the case of there was a Netflix competition where some people use just zip code. I think about 3 data points to zip code, the rating, to be able to tell the person who gave that particular rating. I think it was Netflix, and they had to put the data from the public because people were able to actually decrypt that data, despite the fact that they were able to encrypt the data. So you don't want that to happen. So that means you have to penalize your model along the line of privacy. So 2 things: you have your machine learning efficacy, which is okay, how well has this model carried what it has learned on synthetic data to the real world, and also along privacy, which is how well does it encode the things it needs to encode, and how well does it learn things that matter while leaving out the private information in the data.
All right. So Ewa, thank you so much, for, making mention of those things, right? So in essence, the reason why we are talking about this synthetic data of a thing, it's a big thing, right? It's helping businesses grow. It's helping businesses ship models as fast as they can, right? It's helping businesses share data across their teams, right? And it's helping you protect your data privacy, right? Giving you, top-notch level of data privacy, and we are dealing with all forms of data, image data, video data, CSV data. This platform is something that you can actually try. You can, schedule a demo with us, try these platforms, and actually see how great synthetic data can actually drive your business, your startup, your organization to the next level, right? So here, I thank you so much for, taking out time to, to sharing your knowledge about more like your knowledge from the technical parts, technical side of things for data synthesis and all. And we really
Yeah,
appreciate your time. And we hope that we can always
thanks.
have, whenever we call you, you would always show up.
Yeah,
Right.
sure.
All right, guys. Thank you so much for showing up and giving us audience to listen to everything we have to say about SynX, synthetic data, and the balls thing happening in the AI industry. And I want